joined. We're currently live on YouTube, so yeah, we're free to start. I want to welcome Jaime, who will present us more about Menuinst. Jaime is a very well-known person in the conda community and does a lot of stuff for Conda Force, works at QuantSite currently, and he will tell you more about how Menuinst works and how we can use it. So please go ahead, Jaime.
Hello, thank you so much, Ben. So let me give you some pointers of how we came to work to Menuinst and why. It's quite the story. This project, Menuinst itself, is pretty old as Conda itself. It's part of the Conda core experience in a way, but it's not often mentioned in any tutorial or documentation because it's just a little piece of the infrastructure that happens to run all the time. One reason you might not be aware of its existing is because it was confined to Windows only experience for so long until we started working on that 2 years ago. So basically, Menuinst is the thing that will create that Windows shortcut for you to start your Anaconda prompt or Miniforge prompt when you installed Miniconda, Miniforge, Anaconda distribution. It's a relatively simple piece of software that does a very specific thing, which is processing a JSON file and creating a Windows shortcut out of it. So when we started working on Napari, which is a visualization library or desktop application to help with scientific imaging, and this is Napari, by the way. Yeah, this one. You've seen this logo, that's Napari. And they wanted to have a shortcut like we could have on Windows, but also on other operating systems like Linux and Mac OS. And we took a look at Menuinst, and the old version number 1, had support for Linux and Mac OS, but it wasn't functional. Turns out that Menuinst was forked from something else called AppInst in the Python 1 and 2 era, like super long time ago. It was 2010, 2011. And back then, it used to work on Linux and Mac OS and Windows, but those operating systems were very different in terms of standards back then. So we had XDG was not fully established, and Mac OS has a different application directory structure, many differences. There was no such thing as system policies in Mac OS, so the things as protecting your runtime and so on didn't even apply. So, and all the JSON input files were different across operating systems because Windows had evolved separately from Linux and macOS, while Anaconda was working on that in their Menuinst fork. Anyway, so when we took a look at it in 2021 or 22, we had like basically a project that was only functional in Windows and it had many inconsistencies with the other implementations. So we wanted to see if there was an interest in revamping this project into something more operating system agnostic. At that time, the Conda community had gotten together again to resuscitate or resurrect the SEPS effort. So there was a new energy into more standardization. So I was very excited to try this path in which we would, for the first time, standardize what the Menuinst JSON file should look like. Just something like this. It's a JSON file with several items under this menu items thing, and each of them would end up becoming shortcuts. Oops. So yeah, we tried that path. We wrote a SEP to standardize the things we had tried from Napari. With that in place and the support of the community, we then pushed fast to implement this in the new Menuinst version. It was version number 2 and major. It was basically a rewrite from scratch. So it could have be very well another project, but we decided to keep the brand just to keep things more familiar. And that's a bit of the backstory. The end result is that these days you can include one of these files in your conda package. And as long as this is included in the menu folder in your top level, then you will have conda and other compatible clients if there are, as I've heard, Pixies adding support for this recently. So they will process this JSON file, and then you will end up with something like what we have with Mapper here, an application icon that looks native on your operating system. You have this for macOS, but you also have it on Windows, of course. You will see the icon in it, and then on Linux, you also see it in your menu as well. Okay, so it behaves like one of those things you have included with your system package manager as well. We reuse all the standards that are in place for each operating system. And you see also some other screenshots here because this is part of the installers for we wrote for Napari as well using constructor and constructor, Menuinst, conda standalone, all these things get together in this first user experience. So it's super important that not only just for conda itself or other package managers, but the application delivery story of the conda ecosystem could be better for people that do not want to touch the terminal at all. If you want to package something for your scientific uses and they just need to click through stuff, then this is what we were after with Napari. And it was a significant effort put into making this experience more consistent across operating systems. It was like 3 years of working on this, so we're extremely grateful that they provided the support. And now this used to be a fork for Napari, but now everything was upstreamed back into the Conda ecosystem. And this had like, a lot of ripple effects because I think Spider, the IDE written in Python, also is using this for their application with the same setup, Menuinst and the new constructor and so on. And I think there's another small ecosystem of microscopy called MNE that is also using this. So yeah, it could have been something private for Napari, but the 50% of the efforts we spent were not about implementing the thing, but about upstreaming that thing into the repositories. So yeah, we are super, super grateful. Anyway, that was a lot of history context, but maybe you want to hear more about the technical specifications or stuff like that. So I don't know if you do it with questions at this point of the talk, Ruben, or should I just keep talking?
If anyone has questions, they should feel free to ask, but otherwise you can definitely continue. I don't have any.
If there are any questions, please interrupt me, and I'll be happy to reply. So you might be wondering, how are shortcuts actually implemented? What's the thing you're writing for these beautiful icons to appear in operating system? On Windows, that's essentially a binary file. They usually have the extension that you don't see is .lnk, and it's a binary file proprietary of Microsoft. You have to use the Microsoft APIs to write them. We can navigate quickly to that code. Should be around here. So where I'm importing this from? Sorry, let me check. No, this is it's a C extension, right? Yes. Because we have to use the Windows APIs, we need to get a little Python extension to write those things. Yeah. So it's not too much code, but because it looks like it's a lot of code. In the end, it's about running this function here. Is it? It's a super small one. You create this object, the shell link stuff, and you start like filling in all the fields. It's like the name of the shortcut, the program you need to launch, the path of the icon, description, and some other stuff. Then tons of error handling, and in the end, you just write it to disk. Okay, you persist the file. That's all. But because we need to use the Windows extension and the Windows API, we need to write this C file. It's a bit annoying because, as you can see, most of the lines here is just handling interfacing with Python. We could have used PyWin32 as the wrapper on the Windows APIs, but it's such a heavy dependency for one code that it felt wrong. So, and Menuinst had this extension from the Menuinst 1 era. So we decided to update this and make it compatible with Python 3, Unicode, and so on. Because some of those APIs were still available on Python 3 from the Python 2 era, but they ended up getting deprecated. So with Python 3.8 or 3.9, we were already getting some compilation warnings that would become errors down the line. So this was part of the work as well. But yeah, nothing revolutionary here. We'll come back to Windows later because there's some stuff with the registry that is interesting. But there's the most interesting part, I think, is macOS, and I'll leave that for the last. And on Linux, it's super simple, thank God, open source, and so it works. So because in Linux you have this thing called the XDG standard, the yes. And they implement all these specifications that all desktops should use on Linux operating systems. By desktops, I mean GNOME, KDE, XFCE, all those things. In the end, they have agreed to use this set of files. And they're just plain text files most of the time, and some XML. That's the most complicated you can get. So all we have to do is to refer to the standards and implement the things in the way they have told us to do. I was surprised to see that it was that simple. You will see later how lovely this is in comparison with what we have to do on macOS or Windows. Yeah, implement some of the stuff. So yeah, it's a bunch of ini files. If you're familiar with the .ini, it's like a terminal-like syntax. And yeah, you just write those files in place. Again, they're plain text and things work. That's all. There are a couple of quirks, sometimes with things that interface with the permission system of whether this can use the camera and the GPU and so on. But those things are usually pushed onto the desktop environment, and you just need to make sure that your configuration file is saying the right things in the right way, because some of those file options are not compatible with themselves. And when you are using two fields that are incompatible in the same file, then you might get silent errors, like your shortcut doesn't appear because the desktop environment said, yeah, this is not valid. I'm not going to tell you, but I'm not going to create this little UI for your icon to appear. So you wouldn't get this thing, and you will need to go into the logs of your desktop environment. And then that was the most complicated part. But once you understand why it works like that, then it was quite simple to implement. The tricky part, as I was saying, is on macOS. On macOS, basically you have these applications, right? For example, if I tell Napari, I have this icon here, but Napari is a Python application. There's no single binary. It's not packaged as a macOS bundle. So how do we get this shortcut here? This is actually a folder. This I don't know if you're aware of this, but we're gonna go through it. So I'm gonna open my Finder. And we're gonna go to my applications. So you see all these shortcuts here. They look like shortcuts or binaries, but all these .app things are not executables. They are directories. And you have the system level, like / applications, but you also have one of these things in your home folder. You see here, applications. And this is where my Napari directory is. So I can double click on this, but I can also explore it. And then you get into this tree contents, blah, blah, blah. So if I go to my terminal, then I can show you the tree of that. this is how it looks like, and this is what we create with Menuinst. So macOS creating a shortcut involves creating all this directory of contents. And if things are in the right way, in the right place with the right syntax, you will get an icon in your quick launcher. If not, good luck. This could have been way simpler, but because of how we need to work around Python limitations, we need some forwarders here, as you can see, all these symlinks and stuff. So let me guide you through that and the limitations we found. Essentially, what we are trying to do with this folder is to trick macOS into thinking that this is a full application. But this is not an application. It doesn't contain executables themselves. Python is not here. The runtime is not here. All of this is going to a conda environment at some point. This Python. Right? So initially we started with in this folder you can have a script, and that would be the thing that it's executed by when you open the application. macOS will run that. In principle, it should be named in the same way as the application directory, but you can change that in your plist. This plist is for property list. It's an XML-like file that macOS uses for configuration stuff. There's a lot of them. And you can go into the documentation of Apple and they will see how different fields get accessible here. So macOS will execute this one. This one here is not an application that is written for Napari. There's nothing specific about Napari here other than the name. This is a trampoline that will find this other script here. And that's the one that will be executed in a subprocess. The subprocess is telling us to execute this Python that links to the actual Python in the conda environment. And we need to do this because macOS wants to have an executable running from the directory. So in the process list, you have that thing from the application directory. Otherwise, it's recognized as an external application that happens to be called by your application. So you will see all of this is just in the doc bar, you see a single icon instead of one icon and then an unknown icon on the right, which is the default experience if you just use the bash scripts to run these things. Also, you need the single icon symptom. You need that to happen so your permission system actually works, because otherwise the subprocess doesn't inherit the permissions of the parent process. So things like accessing your downloads folder or your desktop or permissions to use the camera, things like that do not really work. So this is not documented anywhere. It took us a lot of troubleshooting to find the right incantation that works reliably across macOS versions. And also, this has to play nicely with code silence. So the shortcut itself is not detected as foreign. So you don't get this super alarming warning. That was the simple part. Now we can talk about a new layer we have added on Menuinst about system iterations. That was really, really, really tricky. But that's like a separate component, and that is not part of the default open this shortcut experience. So for now, I'm gonna make a pause and see if you have any questions.
So you're saying that if you wouldn't have a Python script that you need to run, then you would be able to just put the binary in the macOS folder, right?
Correct. If it was a CAD Rust application, then just put it here in macOS.
And do you then still need the script for that application?
This script is just the workaround we need for macOS to find a binary file executed. Because if you use a shell script, the actual thing that gets executed or exec in the standard library is bash. So it's bash who is getting the permissions, but not the thing run by bash, right?
Okay, thanks.
it's mostly about finding the way to call your conda environment executable from the application directory as a workaround. So even if you will
That
have a
makes sense.
binary, you will probably have it in your conda environment, not in the shortcut. So you would have to either instrument your Menuinst implementation to do this workaround or to copy the file or copy and write file, something like that. So hard link it maybe works as well, as long as it's under the directory structure of the application, then macOS likes it better. This keeps changing in every major version, so we will probably need to review how this gets implemented. But yeah, it was unnecessarily tricky because it's not designed to work like this.
Okay. Thanks.
And you also have support for custom URL handlers, right?
Yeah, that's the second layer that I wasn't mentioning yet. So I'm going to start talking about it now, if you want. We can talk about what it is and how it can be used. So from the Spider team, we got this feature request that in the previous implementation, because they had shortcuts for Windows before, but in the previous implementation, they were using something they had written manually using NSYS. NSYS is the program and language that will create the installers for Windows. And they had some custom wrappers for all this C API that I was talking about on Windows. So they could create that directly. So they wanted to port that experience over to macOS and Linux as well with all the feature parity. That meant association file types and extensions with the editor. So you can just double click on .py files and yeah, you have those things open by Spider. It's like, yeah, we don't have any of that, but I was looking at the NSYS code and it's supported by the C API. It looks like on Windows, associated a file type with a program is a matter of just a few registry keys. Turns out that Windows has been changing this over time. There several Windows versions, so you have plenty of different ways of accomplishing the same thing, and they all work because Windows has insane legacy support and backwards compatibility. And it's not really clear which one is the most recent. So we've implemented this 3 times now, changing from API to API, because there are some limitations in what you can achieve in newer newer Windows versions if you use the old APIs. But it all comes down to defining a new application entry in your registry in a certain key. You register that with a certain executable, and then separately you have a file type entry that has a key, and then you paired these two things together. This file type key gets associated with this program key. We have been so exposed to putting things in path, binaries in path, so they can execute it, that that's what we default to. So we are used to thinking of paths as the identifier of a binary. But newer Windows versions have a better way. So you can define a binary entry, an executable entry that gets assigned an executable key, and that can be associated with a path. And those things can be anywhere in the system. They will show on path virtually, even if it's not in the directory list. It will be available without having to inject the whole directory in path. That's something to investigate, I think, for the whole ecosystem, because it could be an easier way of having conda available on the terminal default experience, for example, without having to push the whole Python environment there, creating these directories just for conda as workarounds. But yeah, again, I don't know. I'm not a Windows developer, so I'm not very used to navigating their documentation, but finding these pieces of information was tricky. That's for Windows. And with that, Windows must be possibly the most complicated one, because usually it's the most involved one with the very proprietary things. Let's go to Linux. How does this work? Well, let's see. Thank God, XDG standards exist. And again, it's just one more entry in your .desktop file that says, hey, this thing should open these MIME types. And that's all. Then the desktop environment makes sure of registering things in their implementation. but in principle, you just need to register the file extension if it's not known for the desktop environment, and that's editing an XML file in a certain path, and then making sure that the MIME type is mentioned in your application desktop file. That's all. Literally 2 file edits and macOS. And that's something else. So macOS doesn't use a registry, and they don't have XDG. Instead, they have protocols, interfaces for their binaries with Apple events. So when you open a file that is associated with an application, what happens is that Apple will not, you would think that, yeah, I guess that the binary is called with an argument after it, no, in the CLI. That's not how it works in macOS. What happens is that you get an Apple event dispatched to the binary. So your binary needs to be listening to the Apple events. And Python isn't a native macOS application, so it doesn't listen to those things by default. You will need an application to be listening to those events. But you need to start Python first. And so in the end, this cannot be done with Python, essentially, due to bootstrapping problems. If we go back to the tree thing, this little trampoline script that will launch Python calling this does not know anything about Apple events. So what we need for this is a second launcher that you don't see here because this shortcut is not using that part yet. And in this case, the new launcher will register itself as an Apple events listener. And then those arguments will be passed to the original launcher as an argument. But we need a second launcher written in Swift because that's the easiest you can get to that API and included in the contents here. So you end up with a system of 2 sub-applications coexisting. And what's worse, because of the events dispatch mechanism, that thing needs to run as a service during the execution of your actual program. So you have 2 programs coexisting at the same time. But yeah, again, the solution is more or less intuitive and simple once you know what needs to happen. But figuring it out was not very intuitive. And with this, you can get access to those APIs that are existing in the CLI. So you can register in the 3 operating systems. We have the same features implemented very differently, but when it comes to putting those things in the JSON file, is more or less the same interface. You can register file types, and more importantly, maybe more interestingly, URL protocols. So you can, in the case of Napari, for example, we would say Napari : / and if you click on that link on a web page, we could start Napari to open that imaging file from the microscopy, from the department of whatever. And then you can just communicate nicely through hypertext. But I guess if we come down to the conda ecosystem, you could have like a store somewhere, like an app store, where I don't know if you have used GNOME, but they have this extensions thing. You click on the button, and GNOME will open a native app, and you can install the extension from the browser, so you can add more things to your desktop environment. A potential conda-like store could have those buttons and conda : / and that will be registered as a default protocol for your conda client. Could be Pixie opening these environment files or something, and it could be like a native way. Also quite dangerous, I think, but I don't want my package manager to be launched transparently in the browser, but you could do these things with this type of registration. But yeah, we have seen it's quite finicky and fragile. It works in many cases, but when you start adding like policies and restrictions and specific windows, some environments do not really have all the permissions needed to register new protocols in the registry. So in corporate environments, for example, can get tricky to get working. But in a normal installation where you have control over it, we have tested and it works quite nice. So yeah, that's mostly what Menuinst can do for you. Still quite young, haven't seen much use. So we are excited that this is being implemented in other conda clients and possibly getting more visibility, because it didn't have much to begin with, and now it's even more niche because I think in total there are like 5 projects using this. But maybe with more eyes we can make it more popular because it's quite a powerful pattern, I think.
Yeah, exactly. I think if we can like really streamline this experience from like that, if you want to make this, you don't have to understand all of this. That it might be easier for other packages to start adding the menu items to their conda packages, and then we could deal with the actual installation of that. Are there any more questions for Jaime? Or if you have a reaction, Jaime?
Yeah, no, I was thinking that with Pixie, that you have all this metadata already in place, much of that can be used in the shortcut. So maybe if you have like an icon field for your application, if someone wants to define that, so it's prettier somewhere else in the documentation that gets auto-generated, something like that. All those things can be put together for the shortcut experience. So all you have to do is to expose the entry point as a shortcut. And then you don't have to understand anything about all this complexity that we're hiding from you. You will just get your pretty icon in your desktop. That's all. So yeah, that would be super exciting to see.
If no one has a question for Jaime, I would also like to show a little prototype we've been working on, because we've been trying to add this to Rattler and Pixie as well. This Menuinst functionality. I will share my screen. Change screen. They changed how you have to do this in Discord. Can you see my screen? I can actually check on my streaming laptop. Yeah, you're seeing my my terminal, but I think that's fine. So what we did, we implemented the Menuinst logic as a crate in Rattler. So we have Rattler Menuinst now in a PR still, and we also made a PR on Pixie to allow for Pixie Global to use this logic. So if I now do Pixie Global install Napari, doesn't work yet. I have to figure that one out. But we could install a little test app that we uploaded to the Menuinst test channel that we built, which is just a Pixie editor. It will make sure that it understands that it needs to install the menu item. And then you can, you cannot see my full screen, and I wanted to show you my launchpad. Let me share the proper screen, change windows, add windows. I think this is the button. Yes. Great. You can see my full screen now, right? Yes, great. So now you have this little icon here. And if I click on it, it will open just the text edit functionality. That's just a simple implementation. But I can show you what that looks like in code. So this is the recipe that is responsible for that. It has that menu folder that Jaime talked about. Especially important is that file, which I cannot open in Z apparently, and this information here. So on OS X, it opens the text edit, has some extra information that you need to add, and then building that recipe with Rattler build simply works, and then Pixie can find this folder and install you the application. It's not in release yet, but I think we'll have something very soon, and hopefully we can get more people to make icons for their applications and make conda packages a bit more usable for the normal workspace workflow, apart from like just conda environments. If there's any questions on that, please let me know. And otherwise, I want to say thank you especially to Jaime for explaining all of this. I'm definitely going to rewatch some of these parts to debug some more of these issues that I walked into, but this was very helpful to understand it a little better. So thank you.
I have one question for Jaime still that I was thinking of. Like, is there would like now the in macOS like in the app folder points to the Python interpreter in the conda environment? Say the conda environments would be relocatable and you could relocate them to inside the app folder. Do you think you could like have the entire conda thing in there as like kind of that you can like normally you can download an app and like drag it in? Would that be possible, you think? Somehow?
So when we were researching how to do this, this was not just about the shortcuts. In the end, what Napari people wanted was a way to make their application easily installed. So we considered having the whole theme packaged inside the app directory, like a conda environment inside. But as you said, some users might be exposed to the workflow of moving things around when they install an application in macOS. Sometimes you just drag it into applications, right? That's the installation procedure. So that would have broken the prefixes in the conda environment. But we need to know them. That's why we ended up with this other solution, which was to hide the actual environments from the user, carrying this library directory that is supposed to be implementation specific, and then just expose a shim on top, the shortcut. And that's how we ended up working on Menuinst, because we realized that was a natural place for this to fit. So it was not Menuinst, we want that. How do we make it work for macOS? It was like, we want this experience in macOS. How's the best way to get there? It was like a bit more bottom up. So relocation, I think there's a setting in these plist files I said where you can make macOS aware that the binaries inside are not meant to be moved somewhere else. So it can prevent the UI from having this folder moved. I didn't investigate that because we found that key way later in the process and we were happy with what we had. But there might be a way of shipping things inside and then having the user prevent it from moving that. Otherwise, if that's not what you want, what you can make is update the symlinks inside. Because in the end, everything is self-contained. Application directories are meant to be self-contained. The only external dependency is that symlink we have from Python to the conda environment. But as long as you have a way to regenerate those, then it should be okay. Maybe the symlink could be another program that knows something about how to find the environment directory through some middleware with Pixie or something. Yeah, it gets tricky soon because of these launchers and having one parent process.
Yeah, I get it. Yeah. Okay, thanks. Makes it clearer.
If no one else has questions, then thanks for joining, and thanks Jaime again for presenting this information, and hope to see you guys soon again.
And also
Thank you
thanks
so
for
much.
standardizing all of this.
It was our first experience as a SEP provider. Yeah, we can see now we are introducing more changes through your work. You have identified a number of bugs in our implementation that would require re-standardizing some of those assumptions. So we will see how the SEP process helps us there, because we will need to either update the original one or submit a new one if the changes are too drastic. But yeah, I'm learning so much about things I wrote. So thank you all for pushing this to the next level, because it's really, really helpful. And I really enjoyed the conversation today. I didn't get the opportunity to nerd about these complexities with anyone else because no one cared. So this is really therapeutic as well. Thank you so much.
Thank you.
Thank you.
And have a nice holiday break, probably.
Yes, thank you so much. Likewise, enjoy the end of the year.
See you
Bye-bye.
soon.
Bye.
Bye-bye. Thanks for the presentation.